division by t. It says if Laplace transform of f of t equal to f of s, then Laplace transform of this function divided by t is equal to integration s to infinity f of s ds. That is, if we want to find Laplace of a function of t divided by t, then first find Laplace of the function f of t. Then integrate this function between the limits s and infinity with respect to s. In this problem, we have Laplace transform of some function of t divided by t. So according to this formula, this becomes Laplace of sine 3t. I should integrate this with respect to s from s to infinity. This is equal to integration s to infinity. Laplace of sine 3t is given by 3 upon s square plus 3 square ds. This is equal to 3 times integration s to infinity 1 by s square plus 3 square ds. We have integration of dx upon a square plus x square is 1 by a tan inverse of x by a. Using this, it becomes 3 times 1 by a. A in this problem is 3, so it's 1 by 3 tan inverse of the rule of x is played by s, so s upon 3 between the limits s and infinity. We get tan inverse of infinity, which is pi by 2, minus for the lower limit tan inverse of s by 3. Further, we know tan inverse x plus cot inverse x is equal to pi by 2. So I can write my answer as pi by 2 minus tan inverse x becomes cot inverse x. So it is cot inverse of s by 3. Even in this problem, we have Laplace transform of function of t divided by t. So this is equal to integration s to infinity Laplace of 1 minus e power minus at ds. This is equal to integration s to infinity Laplace of 1 minus Laplace of e power minus at. Integrate this with respect to s. This is log s minus log of s plus a between the limits s and infinity. Here we can't substitute the upper limit as we are getting log infinity. So we are supposed to use the logarithmic property for this, that is log a minus log b is always equal to log of a by b. So I will rewrite this one as log of s upon s plus a between s and infinity. We still have an issue in substituting the upper limit as we are getting log of infinity by infinity. But we know 1 by infinity tends to 0. To make use of it, I will rewrite this expression as log of s upon, take the highest power of s common here, that is s taken out, it's 1 plus a by s. Between the limits s and infinity. Here this s and s will get cancelled. So we get, for the upper limit, it is log of 1 upon 1 plus 0 minus log of, take the LCM and simplify it, it is log of s upon s plus a again. So this is nothing but log 1 minus log of s upon s plus a. So my answer should be log a minus log b gives log of 1 upon s by s plus a. It becomes log of s plus a by s, or log of 1 plus a by s. This is once again L of f of t by t. So it is integration s to infinity Laplace of cos 3t minus cos 5t with respect to s. This is equal to integration s to infinity L of cos 3t is given by s upon s square plus 3 square, which is 9, minus L of cos 5t is s upon s square plus 5 square, which is 25. Here we will use integration of f dash of x by f of x. That is, numerator is differentiation of denominator. It is given by log of the denominator. Differentiation of s square plus 9 is 2s. Differentiation of s square plus 25 is also 2s. To introduce 2 in the numerator, I am just multiplying this whole expression by 2 and dividing by 2. So this becomes 1 by 2 times log of s square plus 9 minus log of s square plus 25. Between the limits s and infinity. We still have the same issue. We can't substitute the upper limit directly. So I need to use the logarithmic property. So I will rewrite this one as log of a by b, that is log of s square plus 9 upon s square plus 25. Between the limits s and infinity. Now I will just take out highest degree term out of numerator and denominator. That will give us log of s square times 1 plus 9 upon s square divided by s square times 1 plus 25 upon s square. Between s and infinity. Here s square and s square will get cancelled and 1 by infinity becomes 0. So it will be 1 by 2 times, for the upper limit, log of 1 plus 0 by 1 plus 0, it is just log 1, minus, for the lower limit, I need to replace s by itself. So it will be log of same expression s square plus 9 by s square plus 25. Now by using log a minus log b formula, we get log of s square plus 25 divided by s square plus 9. Or you can also write it as log of square root of s square plus 25 divided by s square plus 9. So by using a log b is equal to log b power a. In this problem, once again we have L of f of t by t. So it is integration s to infinity L of sine square t ds. that's equal to integration s to infinity. To find Laplace, I need to write sine square t as 1 minus cos 2t by 2. 1 by 2 is constant that can be taken outside. So it is 1 by 2 integration s to infinity. Laplace of 1 is 1 by s minus Laplace of cos 2t is s upon s square plus 2 square, which is 4. This is equal to 1 by 2. We know integration of 1 by s is log s minus 2s is the differentiation of s square plus 4. So it becomes 1 by 2 log of s square plus 4 between s and infinity. Here we can't substitute the upper limit again, and also I can't use log a minus log b formula directly. So I need to rewrite the second term as minus log square root of s square plus 4 by using a log b is equal to log b bar a. So now it is log a minus log b. I can rewrite it as log of a by b. It's log of s upon square root of s square plus 4. Now we know the next part. It should be written as log of s upon. Take s square common, and when I take that s square out of the square root, it just becomes s square root of 1 plus 4 upon s square between the limits s and infinity. Here when I substitute the upper limit, it becomes 1 by 2 log of 1 upon square root of 1 plus 0. It just becomes log 1 minus this lower limit. On simplification, it will be the same expression log of s upon square root of s square plus 4. And this can be written as 1 by 2 log of square root of s square plus 4 by s. We can also write this one as 1 by 2 log square root of s square plus 4 divided by s square. The square and square root cancels to give us s. And this becomes log this a bar 1 by 2. That 1 by 2 can be taken out with the same formula. So it becomes 1 by 4 log of s square plus 4 by s square. This can also be written as 1 by 4 log of 1 plus 4 by s square. This is L of f of t by t. So it is integration s to infinity L of cos 5t into sin t ds. Integration s to infinity Laplace of, this is half times sine of a plus b, that is sine 6t, minus sine of 5t minus t, that is sine 4t ds. 1 by 2 is a constant. Integration s to infinity Laplace of sine 60 is 6 upon s square plus 36 minus 4 upon s square plus 16 ds. It's equal to 1 by 2 times. We know this becomes 6 into 1 by 6 tan inverse of s by 6. minus 4 into 1 by 4 tan inverse of s by 4 between the limits s and infinity. So this is equal to 1 by 2 times, there is 6 cancels, 4 and 4 cancels, for the upper limit tan inverse of infinity, that's pi by 2 minus tan inverse of s by 6 minus, once again it is pi by 2 minus tan inverse of s by 4. If you want, you can just cancel pi by 2 with this pi by 2 to write the answer as tan inverse of s by 4 minus tan inverse of s by 6. Or you can express these two expressions in terms of cot inverse, and you can write your answer in terms of cot inverse, like 1 by 2 times cot inverse of s by 6 minus cot inverse of s by 4. Even in this problem, it is integration s to infinity Laplace of e power t sin t ds. Here we have Laplace of product of two functions, in which one of the function is e power et with a is 1. So first shifting property is valid here. So we rewrite this one as Laplace of sin t is 1 by s square plus 1, in which I need to replace s by s minus 1 ds. This is equal to integration s to infinity 1 upon s minus 1 whole square plus 1 ds. What we know is integration of dx by a square plus x square is equal to 1 by a tan inverse of x by a. But in this problem, if I treat this one as x, this is not x for us. So I will rewrite this one as integration s to infinity d of s minus 1. D of s minus 1 is differentiation of s minus differentiation of 1, that is 0, divided by s minus 1 whole square plus 1. This is equal to, it is integration of dx by x square plus a square, which is nothing but tan inverse of x by a, that is s minus 1 divided by 1. This is between the limits s and infinity. When you substitute the upper limit, it still remains pi by 2 minus, for the lower limit it is tan inverse of s minus 1. So the answer is cot inverse of s minus 1. Next is evaluation of the given integral using Laplace transform. The problem clearly tells us it is not about finding the Laplace transform of some function. Instead, we are supposed to find the value of this integral. For that, I am taking the help of Laplace transform. So we can consider these problems as one of the application of Laplace transform. How do we do this? This is basically integration of product of three functions. Here I need to use integration by parts to evaluate this one. Now, instead of doing that, you can take the help of definition of Laplace transform. We know that integration 0 to infinity e power minus st f of t dt is nothing but Laplace of the function f of t. That is, this integral represents Laplace of this function. Now if you compare this integral with the given problem, The limits of the integration are same. In the place of e power minus 3t, I have e power minus st. So I will use e power minus st itself. If in the place of f of t, I will write t sine t as it is. Now this is nothing but Laplace of this function. So which means finally what should be done? In this integral, if I replace s by 3, I will get the value of this integral. Okay, so this is equal to Laplace of t sine t. So this is product of two functions with one of the function is t power n. The formula says it's minus 1 power 1 d by ds of L of sine t. This is minus d by ds of 1 upon s square plus 1. Now its on differentiation gives minus 1 by s square plus 1 whole square into differentiation of s square plus 1, which is 2s. It's equal to minus into minus plus 2s upon s square plus 1 whole square. This is nothing but integration 0 to infinity e power minus st t sine t dt. But we are interested in this, so I need to put s equal to 3 in it. Put s equal to 3. So we get integration 0 to infinity e power minus 3t t sine t dt is equal to 2 into 3 divided by 3 square, that is 9 plus 1, that is 10, 10 square, which is 100. So the answer is 3 by 50. In this problem, I need to consider integration 0 to infinity. I have this exponential function. I will treat that as e power minus st into sine t divided by t dt. This becomes Laplace of sine t divided by t. We know how to find the Laplace of this function. So integration 0 to infinity e power minus st sine t by t dt is equal to cot inverse of s. Here I need to replace s by 1. So that will give us integration 0 to infinity e power minus t sine t by t dt. This is the given integral, that's equal to cot inverse of 1, which is pi by 4. In this problem, the exponential function is missing, so I will consider it as integration 0 to infinity e power minus st, so that finally if I replace s by 0, that will reduce us to this form, cos 6t minus cos 4t divided by t dt. This is nothing but Laplace of cos 6t minus cos 4t divided by t. We know how to find the Laplace of this one. So we have integration 0 to infinity e power minus st cos 6t minus cos 4t divided by t dt is equal to half times log of s square plus 16 divided by s square plus 36. In this one, as I mentioned, I need to take s equal to 0. We get integration 0 to infinity cos 6t minus cos 4t upon t dt equal to 1 by 2 log of 16 by 36. On using a log b is equal to log b bar a, this becomes log of square root of 16 divided by 36, that is equal to log of 4 by 6 or log of 2 by 3.